Welcome to the mathematics in my channel. In this video we are going to evaluate another interesting integral from 0 to infinity 1 over 1 plus x square plus this is going to x to the n. Okay, last week not last week, a couple of weeks ago we evaluate this integral here, x to the fifth power. So if we have here 6 7 8 9 or any positive integer here n greater than to 1, so how to evaluate? Okay, in evaluating this integral I use a trick, but it's not work for other integrals, so I thought to generalize this integral. Okay, first of all, here we know in the denominator we have geometric series, so we can simplify dx over 1 minus x to the n plus 1 over 1 minus x, then integral from 0 to infinity 1 minus x over 1 minus x to the n plus 1 dx. Okay, then I am going to take a substitution. So if we take x to the n plus 1 is equal to t, then differentiate, so n plus 1 times x to the n dx is equal to dt. Okay, then we can plug in here limit, also we know 0 to infinity here 1 minus x, so 1 minus x, now we know t to the 1 over n plus 1, t to the 1 over n plus 1 over 1 minus here x to the n plus 1, we know t, and dx, now we can isolate the dx, we know dt over n plus 1 times x to the n, x we know t raised to the 1 over n plus 1, so t raised to the n over n plus 1. Okay, then here 1 over n plus 1 is a constant, so we can write outside of the integer sign 1 over n plus 1 here 0 to infinity. Now we can simplify, we can write t to the n over n plus 1 in the numerator, so we have here t to the minus n over n plus 1 minus t to the 1 over n plus 1 minus n over n plus 1, so we know 1 minus n over 1 plus n, and here we have 1 minus t dt. Okay, then as a next step here 1 over n plus 1 integral from 0 to infinity. Now I am going to arrange the powers like here t to the, now we can write 1 over n plus 1 minus 1 minus t raised to the 2 over 1 plus n, here 2, so 2 over 1 plus n minus 1 over 1 minus t dt. Okay, now I think this is familiar with us because last week we evaluate the integral and we use this identity, but here in that question we evaluate limit from 0 to 1. This is the integral from 0 to 1 x to the m minus 1 minus x to the n minus 1 over 1 minus x dx, and this is equal to digamma of n minus digamma of m. Okay, but here we have 0 to infinity. Okay, don't worry, here now limit 0 to infinity x to the m minus 1 minus x to the n minus 1 over 1 minus x dx is equal to pi times, before 8 months ago I also evaluate this integral, so we have the answer pi times cotangent of pi m minus cotangent of pi n. Okay, If you like to watch this video, I will add the link in the description and also make a card. So now we can apply this formula. So we can write now this is equal to 1 over n plus 1. Here now we know pi times, so here we can write pi here, so pi over n plus 1 cotangent of, now instead of m we have 1 over n plus 1, so pi over n plus 1 minus cotangent of 2 pi over 1 plus n. Okay, this is the answer. This is the generalization of this integral. Okay, now if we take this integral, so I'm going to take, this is I. Now we know here n is equal 5, so when n is equal 5, our integral I is equal to pi over, here n is equal 5, so 5 plus 1 we know 6, so 5 over 6 cotangent of here also pi over 6 minus cotangent of here pi over 3. So if we simplify, here pi over 6 cotangent of 5 over 6 we know is square root of 3 minus 1 over square root of 3. So square root of 3 times 3 minus 1 2 get cancelled, 5 over 3 times the square root of 3. Also if you want, you can evaluate for any positive integers. So for example, if we take n is equal 7, when n is equal 7, our integral becomes 0 to infinity here dx over now 1 plus x square plus x cube plus x to the 4th power plus x to the 5th power plus x to the 6th power plus x to the 7th power. Now we know n is equal 7, and I am going to take this integral is equal j. So j is equal to, now n is equal 7, so here pi over n plus 1, so 8. Now here cotangent of pi over 8 minus cotangent of pi over 4, cotangent of pi over 4. So here pi over 8, we know cotangent of pi over 8, 1 plus the square root of 2 minus here 1 get cancelled, and we have the square root of 2 times pi over 8. Okay, this is the answer for this integral. And also I'd like to say this is very interesting and very important integrals, two integrals. This is very important to evaluate another integrals and also sums. So if you like my videos, please subscribe this channel. Thank you for watching.